let's do an experiment. Put the day and date of your birthday in the comments. Mine is 7/23, July 23rd. If everybody puts their day and date in the comments, let's see if something interesting happens. Hey everyone, welcome to another edition of What's Picking My Brain. In the past, you guys have heard me say stuff about the birthday paradox, and I've never really explained what the birthday paradox is or how I use that. You guys have heard me say in the past that I'm always looking for two bills with the same serial number, and that the way that I do it is by implementing the birthday paradox. So, what is the birthday paradox? Well, let me take a few minutes just to explain it. I'm not going to go into any hardcore math. There is a little math here, but I'm not going to go into any hardcore math on this one. The birthday paradox looks at what are the odds of people sharing a birthday. Okay, let's put it this way. If you are in a room, how many people do you think have to be in that room for two people to have the exact same birthday? Okay, now there's 365 days in the year, so the average person would say, well, to have a 50-50 chance, you'd probably need half of 365, or about 183 people. What if I told you that it only takes 23 people to have a 50% chance? 23 people equals a 50% chance that two people will share the same birthday. Not that you will have the same birthday as one of the other 22 people, but of the 23 people in the room, that is where we will find the chance being 50%. Now, let me explain that. If we use a smaller number, let's say we use 5. Let's say we've got 1, 2, 3, 4, and 5. We're not saying what are the odds of this person matching to any of these people. We're not saying that, these connections here. We are saying all of the connections, which means what are the odds of person 2 also matching with person 1 or person 5 or person 3 or person 4. The same thing with this connection here and the same thing with this connection here. Okay, that is where you start to get all the combinations. For one person to match another person, that is fairly slim. It's 0.27% to be exact. But when you start comparing everything else, that's when these numbers start to get a little bit bigger. All right. Where'd my eraser go? There it is. All right. So, once again, if you have 23 people in the room, the odds of any of those two people sharing a birth date drop from 1 in 365 to 50%. What number of people do you need in a room to pretty much guarantee it? Well, if there were 50 people in the room, the odds of two people having the exact same birthday, and we're not talking year, we're just talking month and day, 50 people in the room to have the exact same birthday, you are talking that would be 97% that two people would have the same birthday. What if you had 75 people in the room? 75 people in one room, 75 people in one room. The odds of two people sharing the exact same date of birth are 99.99997%. That's 75 people. That is ridiculous, okay? So the reason that works is, like I said, you're not comparing one person to the other 75. You're comparing all 75 to each other, okay? Now, how do I use this? Well, I use this because I'm trying to find two serial numbers that have the exact same number, okay? And we all know that on singles, there are 96 million combinations as far as serial numbers. Well, for me to save $96 million, that would be pretty impressive. There's no way that I am saving 96 million singles in order to do this. So what I have to do is I have to find a number a lot lower than this to be able to save and to be able to try to accomplish this. So what I do is, the first thing I do is I pull out trinaries. Now with trinaries, you're talking about notes that only have 3 different digits, okay? Trinary, here we go. This note has 1s, 4s, and 7s for the serial number, okay? So that's a trinary. So by checking trinaries and by saving trinaries, I don't have to save every note that I find. Now, how much am I saving? Well, like I said, 96 million is the total number, but how many different trinaries are there? Well, according to mycurrencycollection.com and their cool number finder, trinaries are 0.71% of the population of the numbers that you can possibly find. So when you do the math on that, that comes out to 681,600. That number is much smaller than this. So that is why I save trinaries. Because with trinaries, now instead of trying to go through 96 million, now I only have 681,000. Now, look it up here. These numbers are based on 365, okay? I'm not sure it works exactly the same, but if I was to add 2 zeros to this, now we're talking 36,500, and if I was to add 2 zeros to this, that's 2,300. Once again, the math doesn't work exactly, but you can see how all of a sudden, if I have 2,300 notes, oh wait, that wouldn't be that. If I have 2,300 notes, now I stand a much better chance of finding my pairs. Okay, so that's with trinaries, okay? What about quads? I also save quads, and I've told you guys that trinaries don't have a whole lot of value, quads don't have a whole lot of value. Now, once again, according to that website, the number of quads that are there are 0.46%. 0.46% means there are 441,600 notes that have quads. Once again, if you're talking about a number that big, that is a number much smaller than 96 million, okay? It's a lot bigger than 365, but once again, using that birthday paradox, now you can see how I don't have to save 400,000 quads in order to be able to find 2 pairs. Like I said, this was out of 365. I only needed 23 for a 50% shot. I only needed 50. I only needed 75 to have a 99.99999. So yeah, I'm hoping to get that 100%, obviously, but you don't need that many compared to the number that you're going through. So that's why I save quads. That's why I save trinaries. The actual number of notes that I'm going to need to set aside is going to be much smaller than the number of notes if I didn't narrow down these projections. So when you guys see me taking quads and taking trinaries, here are my trinaries. I keep them all together in order, and the back part of this, these are all quads, and they are also in order. Every time I find quads, every time I find trinaries, I put them in order here. Like I said, hoping to find 2 serial numbers that are identical. This explains pretty much the rundown of the odds of me being able to find a serial number like this, which to the average person looks just like a random number. that also will match another random number. So once again, I don't think there's any additional value in quads. I don't think there's any additional value in trinaries, but that does narrow down the search in being able to find two random serial numbers that are matching. There's probably a little bit of value once you can match this, because it is a very difficult thing to do. And if you want more information on the math behind the birthday paradox, there's numerous videos that are out there explaining the actual math behind it. This is basically just the answers to all the math equations that I'm showing here. But the end result, like this note trying to find 4471 7414 to find that particular number would be a 1 in 96 million attempt. But doing it the way that I did it, well, I was almost guaranteed to find it. All right, guys, if you learned anything new this week, go ahead and hit that like button. If you like what you see and you want to see more, please subscribe. Love reading all your comments. Thanks for watching. I'll see you next time.